Hi everybody, this is Miss Kirsch, and this is the Advanced Chemistry, oh, there's the bell, binding the ratio of moles of reactants in a chemical reaction. This is the pre-lab lecture. Oh, sorry about that. Okay, if you have a balanced equation, the mole ratio tells you how much of each one of the things you need, and it tells you how much you should get. So I've got the little Haber process here. It's my favorite equation. And it's balanced, and it tells me I need 1 mole of nitrogen gas for every 3 moles of hydrogen gas. And when I get done, if everything works perfectly, I'll get 2 moles of ammonia. Well, that's all well and good, but what happens if I don't have a balanced equation? Can I still figure out how much stuff I'm going to get, and can I still figure out the ratio of my reactants to my products? And the answer to that is yes, but you got to do an experiment. So we are going to do this experiment, and what you need is you need to listen to this introduction, and at the same time you should have your lab notebook with you, because I'm going to tell you when to pause the video and write stuff into your lab notebook. Okay, so what if you don't know the balanced equation, or you don't know what you're going to be making? If you don't know, what you can do is you can figure it out by an experiment. So that's exactly what we're going to do. Okay, so the first thing that we're going to do is we're going to make 2 solutions, and I'm going to call them solution A and solution B. And I have to know how strong those solutions are. I have to know the concentrations. So because I'm going to be making them up, I'm going to tell you, and they'll be all labeled. The second thing is you're going to mix the solutions, and you're going to do different ratios of each. So you're always going to use, you're going to use like 5 mils of A and 45 mils of B, and then you're going to use 10 and 40. But you've got to write down how much of each you're going to use, and the total volume should always be the same. Okay, then you're going to measure some kind of reaction. So you're either going to measure the amount of heat that's given off, or you're going to measure the amount of gas that's given off, or how much precipitate is made for each trial. This method is called continuous variation. The property that you're going to be measuring is always the greatest when the mole ratio of reactants is closest to the balanced equation. So for example, if you're measuring gas, the maximum amount of gas will always be when you get the ratio right. So if you're using 20 milliliters of A and 30 milliliters of B, and you get the most gas, then your ratio is a 2-to-3 ratio. The variables that you can measure is you can measure color intensity if it gives off a color. You can do mass if it makes it precipitate. You can filter it and dry it and weigh it for each trial. You can measure the temperature change for each trial, or you can measure the volume of gas produced, but you got to do it for each trial. Okay, so variables are the things in science that we change and measure. So variables come in basically 2 forms. They can be either discrete variables or continuous variables. A discrete variable would be like the days of the week, Monday, Tuesday, Wednesday, Thursday, and there's nothing in between. You can't get Monday and a half. Continuous variables are things like time, where you've got 1 minute, 2 minute, 3 minute, 4 minute, and then you've got seconds in between. So you can measure 1.5, or you can measure 1.2. And most variables in chemistry are what we call continuous. In this lab, we're going to measure temperature. So temperature is, the maximum temperature is going to be when we're closest to the balanced equation. So we want to know what combination of A and B is going to give us the maximum temperature generated. Okay, sorry about that. I had to pause while I had a couple of juniors come in. All right, so here we go. This is the graph of what we're going to make. if you look at this, we've got two compounds. We've got silver nitrate and we've got potassium chromate. And what they do is they change the amount of that they use each time. So the first time I used 0 potassium nitrate and 50 mils of potassium chromate. And then I go 5, 45, 10, 40. You always keep the total volume the same. 15, 35. And at each trial, I record the temperature. So you can see when it gets to 35 mils of the silver stuff and 15 mils of the potassium stuff, that's when I have the maximum temperature. So that's going to be my ratio right there. If you look at that, it's going to be 3.5 to 1.5 ratio. So what is that, a 7 to 2 ratio? So that's what my balance equation is going to be. It's going to be 7 silver nitrates to 2 potassium chromates. So this is basically what you guys are going to do. But instead of measuring grams and the mass of the precipitate, you guys are going to be measuring temperature change. So you're going to have two lines. You're going to make a graph just like this, and one line's going to be going up, and then all of a sudden the data is just going to drop right off like a rock. So then you'll draw a line going down, and where the two lines cross, this ratio is going to tell you what's the best ratio in the balanced equation. Okay, so our reactions are all exothermic, so we're going to be measuring heat. And this experiment is designed so that the total volume that you use is always 50 mils. Okay, so the title is Finding the Ratio of Moles of Reactants in a Chemical Reaction. All right, pause the video and write that in your lab book. Also, the next thing is the date, so write that in as well. So pause the video and write that in. Okay, next thing is the purpose. The purpose of this lab is to determine the ratio of reactants in a reaction using the continuous variation method. Write that in. Materials. We're going to be using two chemicals. Sodium hypochlorite, which is really bleach, at a 0.5 molar concentration. So it's going to be 0.5 moles per liter. And then we're going to be using solution B. I'm not going to tell you what that is yet until the very end. And we're going to use the same concentration of that. Your materials, we're going to be using a styrofoam cup, a digital thermometer, a bunch of beakers, and some graduated cylinders. Pause the video, write that in your notebook. Safety precautions. You don't need to write these in your notebook, but please read these on your lab sheet. Sodium hypochlorite is bleach, so you don't really want to get this on yourself, and you definitely don't want to spill it all over yourself. Okay, pre-lab questions. What I want you to do is in your lab notebook, I want you to use the data that's in your pre-lab, and I want you to sketch a graph in there. The graph should have a line going up and a line going down, and where they cross, that's the optimum ratio for the balanced equation. So I want you to sketch it in your lab notebook and be prepared to discuss it when you come in. So pause the video and do that. Procedure. The procedure that we're going to use is exactly the same as in the paper. So, except for the step number one. Step number one, what I want you to do is I want you to change it to say, obtain a flask of 0.5 molar NaClO and a flask of 0.5 molar solution B. You're just going to have the two flasks. There's no reason pouring it into extra beakers. It's just more stuff to wash. Forget about that. So now I want you to pause the video and copy the procedure from the note pages or the lab pages into your notebook, and you can copy the rest of the steps of the procedure just as they go. Now we're all ready to go. So this is the end. You bring your notebook with you, and I will see you when we start it.